Read once. I'll explain. I'll come into picture. No, to what you have to find out the resistance using Ohm's law. So what is Ohm's law? V proportional to I. So R equal to V by I. So what is that? What is the thing? This is the thing which is a wire, resistance wire is telling a this what I'm rounding off. By using voltmeter, and there's a rheostat. By wearing rheostat, I can control the current. So what is the duty of this rheostat? I can vary current. So in exam, very simple thing. The rheostat that is used in the uh, ohms are using voltmeter, ammeter. What happened? Well, what it determine? It will determine the current flowing through the circuit. So for different values of current, I can measure the voltage here. By shifting the rheostat contact, reading of ammeter and voltmeter are noted down. This, I think this is the most important part of the experiment. I'll underline it so that you can notice it. It's very simple. Nothing. So we'll note down that one. So at least for 6 observations, we take it. So more number of observations, better. The random error will be minimized. So what is the basic idea? Random error is inversely proportional to number of observation. This is applicable for any experiment what you do. What about systematic error? Systematic error and number of observations, not related. At least 6 is telling. Less than 6, then the random error what happened will not get minimized here. If you take more 10 or say like 10, 15, 20, oh, well and good, still the random error will get minimized. Okay, the R equal to, so the slope is what we are going to calculate. That slope is what I'm going to determine here. I'm going to place it here. From where do I calculate? Tan theta. Delta V by delta I, it should be written. Huh? So you'll get confused from where delta V brought. That's why the author has made only V by I. How to calculate V by I? The slope, tan theta. Okay, let's get into this particular thing. Okay, now after getting the resistance, what happened from there? What happened? We'll get the resistivity of material. Or specific resistance, what we call specific resistance, or called also resistivity. Both either thing. Specific resistance, or it is also called as a resistivity. D rho by rho. I think this from error analysis. We'll put like this here. So when you measure the diameter, length, voltmeter, ammeter. Now tell me like it to minimize the relative error. This is called like a relative error, no? Or random error. So to minimize the error in the measurement of resistivity, any conditions for voltmeter and ammeter? What should be the resolution of them, or resolution is smallest? So one student will do this experiment by micrometer, microammeter, then milliammeter. Tell me where the error will be more. Delta I will what happen will, what is the smallest length I can measure? 1 milliampere. So one student will choose milliammeter, other will choose microammeter, where the scales will be like this. 0, smallest division is 1, 2, 3, 4, 5, 6, 7. Next we have microammeter. Okay, this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 microammeter. Now which one should be preferred? Microammeter or milliammeter? What is the smallest current you can measure? 1 milliampere here. 1 microampere. So this should, so 1 milliampere, this is a microampere. So this should be the preferred, no? The ammeter. Able to get this one? So delta V, delta I. What is delta V, delta I? If they give a scale. So what is the troublesome question for you in exam is, they may give this diagram. Huh? They will indicate this scale. For voltmeter and micrometer, they'll indicate scale. And they don't give this value, delta V, delta I. So you should not say it's out of syllabus. I think from that smallest division. So what is the year? Let me call this as voltmeter. It'll be better, no? Yeah, 10 microvolt. Okay, 10 I'll write it. It'll be understood. Milliampere. So what is delta I? 1 milliampere. What is delta V? 1 microvolt. That is what you're supposed to substitute here. They may trouble you of like this, the diagram based. You be careful. Delta V, delta I. And what is the length of the wire? I'm going to use a scale where the smallest length I can measure is 0.1 centimeter. If I use 1 year caliper, the length of the wire, usually we go for some scale something new. So the smallest division there will give delta L. And this will be screw gauge. There's no doubt we are going to measure from that one. Please do be alert, because I as a teacher, I'm just sharing the information. In exams, you should have the basic observation skills. Either way, they can put all these things. Any doubts, if you have, you can ask me. Any doubts? Okay, I'll go for the next one. Meter bridge experiment.